Yeah, good afternoon, students. Good afternoon. Hope you are all good and safe. So, am I visible and audible to JNB Bhavnagar students and to the students who are watching from YouTube? Just let me know in the chat box. Students, am I visible? Can you see my screen? Am I audible? Bhavnagar students, can you hear me? If you can hear me, just put it in the chat box that you can hear me. Can anyone give me a response from your side? Are you guys there? JNB Bhavnagar. Hello. Yeah, yeah, okay, okay. Thank you so much, dear students. So let's start the class, okay? So in this session, we are going to discuss the questions on the topic P block elements. Okay, so P block elements consist of group 13 to group 18. So here in this session, we are going to deal with your class 12 of P block, that is group 15 till group 18 questions. Okay, so so our nitrogen group, oxygen group, and halogens and your noble gases. Okay, so the questions from these groups are going to be discussed here in this session. So let's start with the first. Okay, so coming to the first question for today. So given below are two statements. So statement one says that SbCl5 is more covalent than SbCl3. Okay. And statement 2 says that the higher oxides of halogens also tend to be more stable than the lower. So we have to find out the most appropriate answer from the options given below. Okay. So I'll give you some 30 seconds to 45 seconds to solve this question. If you have got the answer within that time limit, you can put it in the chat box. Okay. So try for the answer and try to let me know the correct answer in the chat box. Okay. Then we will discuss. Has anyone got the answer? Jaini Surendra Nagar, good afternoon. Okay, let's discuss. Okay. So now coming to the statement one, coming to the statement one. So it says that SbCl5 is more covalent than SbCl. So we have to find out the oxidation state of that antimony. Sb is antimony, right? So we have to find out the oxidation state. So here in SbCl5, the oxidation state of antimony is +5 and here it is +3. Okay. So we know that from Fajan's rule the charge on the cation, the charge on the cation is directly proportional to the covalent character. Okay? Charge on the cation is directly proportional to the covalent character. If the charge on the cation is very high, then the covalent character is also very high. Okay? So this relation we are getting from the Paget's rule. The Paget's rule you might have studied in your class 11 of chemical bonding. Okay? So according to this rule, SbCl5 is more covalent because it is having the highest positive charge. Okay? So statement 1 is correct. And coming to statement 2, the higher oxides of halogens also tend to be more stable than the lower ones. So let me give you the example for the oxides of halogens. Okay. So oxides of halogen means oxygen and halogen containing compounds. Got it? Now I'll give you two examples. One is Cl2O7 and the other one is Cl2O. So these two compounds are the oxides of halogen, that is chlorine. In the first compound, if you can find the oxidation state of chlorine, you will get +7. Okay. And in the second compound for chlorine, we will have +1. Now, the compound, the oxides of halogen, which is having the highest oxidation state, that is more stable than the lower ones. Okay. So, because halogens are highly electronegative in nature. Halogens are highly electronegative in nature. So they will stabilize the highest oxidation state. So highest oxides of halogens tend to be more stable. Okay, because they can stabilize the highest positive oxidation state. So statement 2 is also correct. So here option A, that is both statement 1 and statement 2 are correct is the answer for this question. Okay. I hope this is clear to all of you. If you're having any doubt, just let me know in the chat box. We will discuss it again, okay? I hope there is no doubt. Okay, I'll move on to question number 2. I'll move on to question number 2 for you. So, which of the following statements is not true for halogens? So, 4 statements are given. We have to find out the incorrect statement for halogen, okay? So, in option A, all are oxidizing agent is given for halogen. All are oxidizing agents. Yes, all the halogens are oxidizing agents. So that is the correct statement. And all form monobasic oxyacids. That is also true. All contains only one hydrogen containing oxyacid. So that is also true. All but fluorine show positive oxidation state. Fluorine shows positive oxidation state. So that is incorrect. That is incorrect. Fluorine always shows minus negative oxidation state, which is -1, because it is the most electronegative element, right? So it will always gain the electron from the atom to which it is bonded. So when it always gains the electron, it obviously gets negative oxidation state, right? So it cannot be positive. It will always be negative, and that is -1 for fluorine. So option C is incorrect for halogens. Okay. So that will be the correct answer for this. And coming to the fourth statement, chlorine has the highest electron gain enthalpy among the 4 halogens. Yeah, that is correct. So when you move from top to bottom, electronegativity decreases. Electronegativity decreases, but there is one exception. You might have studied in this lesson. Chlorine will have the highest electron gain enthalpy value compared to fluorine. Okay, that is an exception. So that is also correct. So option C is the correct answer, which is the incorrect statement regarding the halogens. Okay, fine. Now let's move on to question number 3. Which is the correct thermal stability order for H2E, where the element, that is E, is oxygen, sulfur, selenium, tellurium, and polonium. So these elements are group 16 elements. Okay, these elements are group 16 elements. So they are forming the hydrates of formula H2E. We have to find out the thermal stability order for them. So what could be the correct answer? Can you guys try for it? What could be the correct thermal stability? While discussing the class also, we have studied this. Any idea for anyone? Which is the correct thermal stability order? Okay, let's discuss here. The thermal stability depends on the bond dissociation energy. Okay, so thermal stability is directly proportional to the bond dissociation enthalpy or energy. Okay, so if the bond dissociation energy is very, very high, then the particular molecule is more thermally stable. Got it? Now we have to find out the molecule which has very high bond dissociation energy. So what is bond dissociation energy? The energy required to break the bond is called as bond dissociation energy. Okay. Now coming to the hydrates of this group, first let me go with oxygen. Oxygen is very small in size. So this is OH2, and coming to sulfur, so this is the size of oxygen, and the sulfur size would be little bit bigger than oxygen. Okay, and they will have some bigger bond length. And coming to selenium, selenium is still bigger than sulfur, so the bond length would be very, very high for selenium, and tellurium it is still high, and for polonium also it will be very, very high. Okay, it will be large. Polonium hydrogen bond will be very, very, it is very lengthy. Okay. Now, if the bond length is very small, the energy required to break that bond is more, right? Because bond dissociation energy depends on the bond strength. If the strength of the bond is very high, then we have to supply more energy to break that bond. Okay. Now, this OH bond is very short. So, what is the meaning? More energy is required to break this bond. So the bond dissociation energy is very, very high for OH bond. So it is thermally more stable compared to the other. Got it? So if you can check for that. And the order, thermal stability order, decreases on moving down the group. Okay, so oxygen, sulfur, selenium, tellurium, polonium. If you are moving down the group, bond length between the hydrogen and the element increases, and the bond strength decreases on moving down the group. If bond strength decreases, bond dissociation energy also decreases on moving down the group. So the last element will have the very less bond dissociation energy. So it is least thermally stable. Got it? And OH will have the highest bond dissociation energy. So it is more highly thermally stable. So option A will be the correct answer for this question. Got it? So this is how you have to go for this. Just study this relation alone. Okay? Very easy relation. Just remember this relation to find out the answer. Okay. So now let's move on with the next question for today. That is question number 4. Yeah. Just a second. Explanation. Okay. Fine. The most stable trihalide of nitrogen is the most stable trihalide of nitrogen is the most stable trihalide of nitrogen is. Already the explanation is to you on the screen, okay? So the answer will be NF3. Answer will be NF3 for this. So the stability of trihalides decreases on moving down the group. Why? Because the nitrogen halogen bond gets weakened down, and the nitrogen cannot it cannot accommodate the large size halogen atom around it. Okay, since because of its very small size, it cannot accommodate the large anion, that is the halogen around it. So that is the reason. So the most stable halides of nitrogen will be the one which is very smaller in size, that is fluorine. So NF3 will be the most stable halide among the things, because bond length gets increases, no? So NF, NCl, and this is NBr, and this is your Na. Again, the same concept. The bond length increases and the bond strength decreases. So we can easily break this bond. So it is Ni is not stable. Ni3 is not stable, but NF is highly stable, and because the energy required to break the bond is very, very high. So it is relatively more stable compared to the other halides of nitrogen. Okay. So option A is the correct answer for this. Okay. Now let's go with question number 5. In which one of the following arrangements the given sequence is not strictly according to the properties indicated against it? So in 4 options, we are having 4 different orders. We have to find out the incorrect order because they are asking the sequence which is not strictly according to the property. So we are asked to find out the incorrect order. Okay. So can you guys try for it? Try for the answer. Is option A order correct? So in option A, increasing oxidizing order is given. So lead oxide is having the very high oxidizing nature. As we all know, on moving down the group, the oxidizing power increases, right, for oxide. So that is correct. And coming to option B, acidic strength is given. Yeah, HI is a strong acid and HF is a weak acid. So the given order is the increasing order of acidic strength. Okay. Now coming to option C, the hydrates of group 16 are again given, and they are saying that it is the increasing pKa value. So what is pKa? Actually, pKa is inversely proportional to acidity. pKa is inversely proportional to acidity. If the compound is having the highest pKa value, then it is least acidic in nature. Okay. So which compound is least acidic among these 4? Which compound is least acidic among these 4? H2O or H2T? It is actually the tellurium hydride, right? Because in the previous question only I have told you the bond length between a big sized tellurium and the hydrogen, it will be more compared to the small sized oxygen and hydrogen. Okay. So we can break this tellurium hydrogen bond easily, and the hydrogen goes out as H plus easily in case of tellurium hydride. Okay. So tellurium hydride is more acidic. Tellurium hydride is more acidic compared to H2O. So if it is more acidic, if the acidity is more, then the pKa value should be very less for tellurium hydride, right? But you see, pKa value is more for tellurium hydride. It is given that tellurium hydride is having the highest pKa value, which indicates that it is least acidic. That is actually incorrect. Since it is more acidic, pKa value should be very less because pKa and acidity are inversely proportional. More acidic substance should have the less pKa value. So the symbol is wrong and the order is wrong. Okay. So it is actually the other way around. So option C is not strictly following the property. Okay. So that is the correct answer. When coming to option D, you can see the increasing acidic character. Acidity is increasing on moving down the group for group 15 element hydrates. So nitrogen, phosphorus, arsenic, antimony, these 4 are group 15 elements, and they are forming the hydrides on reaction with hydrogen. Usually on moving down the group, size of the atom increases. So the element hydrogen bond can easily be broken. Hydrogen can come out easily. So on moving down the group, acidity increases. The same concept which I have explained for this, okay, will follow for this also. So antimony hydride is more acidic in nature since it is the 4th member of its group compared to arsenic hydride and pH3 and NH3. Okay, so that is the correct acidic character order. So option C is the correct answer. Actually, it should be the increasing acidic character order. Okay. It is increasing acidic character order, but since they have given pKa value increasing order, it is the incorrect answer. Got it? Now moving on to question number 6. Moving on to question number 6. So two statements are again given to you. So chlorine can easily combine with oxygen to form oxides, and the product has a tendency to explode. Chlorine can easily combine with oxygen to form oxides. Yeah, that is correct. Chlorine and oxygen, they form Cl2O7, Cl2O, ClO. So many compounds are possible. They can combine. Both of them can combine and they can form the oxide. And the product has a tendency to explode. Yes, some of the products like ClO, ClO2. So these oxides are, they have the tendency to get exploded. Okay. So statement 1 is correct. If you go through the halogen part of your P block elements in your book, you can find this. So they have the tendency to explode. So statement 1 is correct. Statement 2 says that chemical reactivity of an element can be determined by its reaction with oxygen and halogen. So we can able to find out the reactivity also by the reaction between this halogen and oxygen. If you take fluorine as a halogen, if fluorine reacts with oxygen, fluorine mostly it is highly exothermic in nature and the reactivity will be very, very high. Okay. If you take iodine, all the reactions with iodine, they are extremely very slow. So we can able to find out the more reactive and less reactive thing. That is, we can find out the chemical reactivity of an element. Okay. That can be determined by its reaction with oxygen and halogen. So both the statements are correct. So option D will be the correct answer for this question. If you don't know this concept before, just now you will learn this. Okay. You don't have to worry about it. So because this P block elements is not a part of your CBSE, it is actually deleted, but it is included in NEET and JEE from this year onwards. Okay. And the whole lesson is not there for the exam, but only very small topic. Very small topic of each group is included. That is the basic concepts and physical properties, some of the general chemical properties, and the anomalous behavior of first member of all the groups. Only these 4 topics are included for your exam. And the compounds of this group 15, 16, 17, 18, those are not included. Okay. So that is a major part of this lesson actually. That is deleted. So you don't have to worry about it. Only the very small part of each group is added so that you can concentrate on it and study from the book. Okay. We are also discussing questions from those topics only. So the answer is option D for this. Now coming to the next question. Noble gases are named because of their inertness towards reactivity. So the term noble gases itself says no that they are inert. They will not react with any other atoms. So because of their inertness, they cannot react with other elements so easily because the outermost shell is already fully filled. So we have to find out the incorrect statement regarding this noble gas. Got it? So let's check from the first option. So option A says that noble gases have large positive values of electron gain enthalpy. Yeah, that is correct. Actually, the electron gain enthalpy for an element should be more negative. Okay, what is electron gain enthalpy? The tendency, the energy released when an atom takes an electron. We are adding an electron from outside to an atom. That atom will release some energy and that energy we call it as electron gain enthalpy. Okay. Now that electron gain enthalpy value should be more negative. If it is more negative, the value says that the particular atom can take the electron so easily. Or we can say it in the other way around also. We can say that we can add that electron easily to that atom. Okay. But since noble gases are having the large positive value, positive value denotes that we are not able to add the electron to noble gases. That is correct because they are already completely filled. They are already having a completely filled shell, balanced shell. Okay. So the addition of electron is not favorable to that. That's why they are having the large positive value. So option A is the correct statement. Coming to option B, the noble gases are sparingly soluble in water. Yeah, sparingly means a kind of partially. Okay. They will not get dissolved in water completely. They are sparingly soluble. So that statement is also correct. Noble gases have very high melting and boiling point. Actually, the statement is incorrect for noble gases because they have very low melting and boiling point. So why? Why they are having very low melting and boiling point? So they will not come and form the bond with each other, right? Because since the outer shell is completely filled, if I want to take an example, let me take neon for you, okay? Let me take the neon as an example for you. Neon is a noble gas. So let me take two neon. Now the outermost shell of neon already contains 8 electrons. Outermost shell already contains 8 electrons. So the second neon, it also contains 8 electrons around it. So if they are already fully filled, they are not going to come and form the bond with each other. Okay. So what they will do, they will try to come in contact with each other, but they will not form the bond. Okay. Since they are trying to come in contact with each other, there will be some force of interaction existing between them. And that interaction we are calling as van der Waals interaction. There will be some interaction when two noble gases are solidified. When they are getting solidified, there will be some interaction acting among them. So that is called as van der Waals interaction. So van der Waals interaction is actually one of the very weakest interaction among all. Okay. So what happens? The interatomic interaction, what they're calling it as van der Waals interaction, that is very, very weak. If this bond is very, very weak, and if the interaction is very, very weak, we can break this so easily. Okay. So at very low temperature itself, the compound can boil and it can melt. We don't have to supply more amount of energy. Okay. To get the highest boiling point and to get the highest melting point. Got it? So at very low temperature itself, they will melt, they will get melt and they will boil because of the very weak interatomic interaction. Got it? So the one of the very important property regarding the melting and boiling point of noble gases, they have very low values of these. So option C is incorrect for noble gases, which is the correct answer for this question. And if you want to see for option D, noble gases have weak dispersion forces. Yes, dispersion means a kind of London forces. When they try to come in contact with them, the negative part and the positive electron density, they will try to form the bond. Okay, by the dispersion of that electron cloud, they will try to form the bond. And that interaction is also very, very weak. Okay, so that is correct. So option C is incorrect for the noble gases. Clear? Yes. We will move on to the next question now. We will move on to the next question. The dinitrogen and dioxygen, the main constituents of air, they do not react with each other in atmosphere to form oxides of nitrogen. Why? What is the reason? In the atmosphere, we are having many different gases, but nitrogen and oxygen, N2 and O2 are the major constituent of the air. But even though they come in contact with each other, they are not reacting with each other to form the nitrogen oxides or the oxides of nitrogen. What could be the reason? What could be the correct reason for that? Can you guess? Can you guess for it? They do not react with each other. Why? Nitrogen is unreactive in the condition of atmosphere, they are saying. Okay, nitrogen is unreactive only, but it can react at very high temperature. Can react at very high temperature. So in the atmosphere, we can increase and decrease the temperature, right? So that cannot be the answer. And coming to the next statement, oxides of nitrogen are unstable. No, they are stable. If you are trying to form the bond between nitrogen and oxygen at very high temperature, those nitrogen oxides are stable. Okay, they are actually stable. So that also cannot be the answer. Reaction between them can occur in the presence of catalyst. So in the atmosphere, we are not having catalyst or what? We cannot able to add the metal catalyst in the atmosphere, and due to that reason, they are not reacting, they are saying. So that cannot be the appropriate answer. And option D says that the reaction is endothermic and it requires very, very high temperature. So what is endothermic? Absorption of energy. Absorption of energy. Yes. Actually, nitrogen is unreactive. Nitrogen is unreactive at normal temperature. Okay, at room temperature. But when you try to react them at very high temperature like 1483 to 2000 Kelvin, if you are giving heat, that nitrogen and oxygen will absorb this heat energy. Will absorb this heat energy. So energy is getting absorbed and it forms the oxides of nitrogen of formula NO. So if you balance it, you have to put 2 NO. Okay. So it is reacting at very high temperature and the reaction is reversible. So basically what it is doing, the nitrogen and oxygen, they are absorbing the energy what we are giving. So they are ready to react at very high temperature by absorbing the energy. So that's why it is called as endothermic, since they are absorbing the energy. And since they require very high temperature, they are not reacting with each other under normal condition in the air. Okay. So that is the only reason for nitrogen and oxygen to not get react with each other. Got it? Actually, they will react at very high temperature by absorbing the energy. That is the answer. Option D is the correct answer for this question. Reaction is feasible at very, very high temperature. Actually, 2000 Kelvin, 1500 Kelvin is itself very, very high. Okay. But since we are not providing any such temperature and the temperature of the atmosphere is also now not that much, they are not reacting. Okay. So I hope this is clear to all of you. Let me move on to question number 9. Acid strength increases in the order given as. So statement 1 gives the acidic order of the acids of group 17. So in the previous, just before few minutes only, we have discussed, right? HI is the strong acid and HF is the weak acid. And the acidity increases on moving down the group because the bond length will increase, right? So the order is correct. Statement 1 is correct. As the size of the element fluorine, chlorine, bromine, iodine increases down the group, the bond strength of these compounds decreases, so the acidic strength increases. So this statement is also correct, right? So on moving down the group, what happens? The HF, HCl, HBr, and HI. The bond length is actually increasing. Bond length and bond strength, they are inversely proportional, right? If bond length is increasing on moving down the group, bond strength is decreasing. So HI is having the very, very weak bond. Bond strength is very less for HI. So we can easily break this HI bond. And if this bond gets broken down easily, the hydrogen can come out easily. So the compound which gives out this H plus ion so easily are called as acids. And that's why HI is a strong acid. Okay. So statement 1, statement 2, both are correct. Okay, so option B is the correct answer for this. So is this clear to all of you? Shall we move on to question number 10? If you're having any doubts, just inform me in the chat box, okay? I will move on to question number 10. Which one of the following group 15 hydride is the strongest reducing agent? Which is the strongest reducing agent? So reducing agent means they will give out the hydrogen so easily. Those are called as the reducing agent. Now, the given hydrides, they belong to group 15. Nitrogen NH3 is not given, but phosphorus, arsenic, antimony, and bismuth. So these four element hydrides are given to us. Now, we all know that, on moving down the group, the bond length between the element and the hydrogen, it increases, right? Let me take like this, okay? pH, and after phosphorus, arsenic comes, so ASH, then your antimony, then bismuth. Okay. Now, if you can see here, the length increases on moving down the group. So bismuth can give out its hydrogen so easily because the bond length is very high. We can break the bond. Same concept only, which we have discussed in the previous question. Okay. So this bismuth hydrogen bond can be broken down easily. Hydrogen comes out. Acidity is more for that. And also we can say reducing nature is also more for the compound which is giving its hydrogen so easily is called as reducing agent. Since bismuth is giving its hydrogen easily because of its very weak bond, that is the strongest reducing agent. That is the strongest reducing agent. Since the size of the bismuth is very, very large, it can be broken down easily. Okay? So, reducing nature increases on moving down the group. For all the groups, hydrides, this is the order. Okay? These are the general orders, general physical properties. Under general physical property topic, you can see all these things. Okay, physical and chemical properties consist of this. So option B is the correct answer. Now coming to question number 11, again a statement type question. The boiling point of the following hydrides of group 16 elements increases in the order oxygen, sulfur, selenium, and tellurium. So here, tellurium, that hydride is having the highest boiling point value according to the given sign condition. So it is clear that the last compound is having the highest boiling point. Is that true? On moving down the group, is that true? Basically, we all know that H2O is having the highest boiling point because that H2O molecule can form the hydrogen bonding. H2O molecule can form the hydrogen bonding. It can form the hydrogen bonding, and this is called as hydrogen bonding, and this bond is very, very strong. So more energy is required to break that bond. So H2O molecule will get boiled so late. It requires very high temperature to break the bond. Okay. So due to hydrogen bonding, H2O molecule is having the highest boiling point. So that type of hydrogen bonding is not present in case of sulfur, selenium, and tellurium containing hydrides. So in all these three hydrides, we cannot see the hydrogen bonding because of the very small size of the central atom. They will not go and form the very strong bond with the other element hydrogen. So they don't have the tendency to form the hydrogen bonding. So what type of interaction they do have? They also have some interaction. That interaction is called as van der Waals interaction. These elements are having, these compounds are having van der Waals interaction. But as I have already told you, van der Waals interaction is one of the very weakest interaction among all. So when you compare van der Waals and hydrogen bonding is more stronger compared to van der Waals. So the compound which can able to form the hydrogen bonding will have the highest boiling point. Okay. So the given order is incorrect. The actual order should be the H2O having the highest value. Okay. So statement 1 is incorrect. So now coming to statement 2, the boiling points of these hydrides increase with increase in molecular mass. Actually, the statement 1 order itself wrong, right? So in statement 2, the explanation is given for the order given in statement 1. No, it is actually incorrect. Boiling point of these hydrides increases as the molecular mass increases. Boiling point also increases, but not in all the cases. Okay, but it is not with all the cases. So in some cases like this H2O, since they are able to form this type of hydrogen bonding interaction and all, there will be some exceptions. Okay, tellurium is having the highest molecular mass value compared to oxygen. Okay, but due to this hydrogen bonding, there is an exception arising. So that statement 2 is also incorrect. So both statements are incorrect is the answer for this question. Okay, both the statements are incorrect. Clear? So let's move on to the next question. The total number of acidic oxides from the following list is the total number of acidic oxides. So who are the acidic oxides? The compound which contains the more positive oxidation number is actually the acidic oxide. Okay. So here NO, NO, N2O and NO is actually neutral, N2O is neutral and CO. So if you check for these three, so these three oxides are neutral oxides. These three oxides are neutral. So how do we know that it is neutral? This concept is related with the periodic classification of elements lesson from your class 11. Okay, there the last topic of that lesson you can find this. So these three elements were given under the neutral oxides. So these three are neutral. Now coming to B2O3, it is an electron deficient compound. Boron is electron deficient. Nitrogen is present in the highest oxidation state, that is +5 in this compound. And here boron is present in +3, and sulfur is present in +6. You all know how to find out the oxidation state, right? So if I want to find out the oxidation state of sulfur in SO3, what I have to do? I have to take the sulfur as H, and each oxygen will have -2 charge. We have 3 oxygen, so 3 into -2 is -6 equal to 0, X is equal to +6. Okay, like this only you have to find out the oxidation state for all the central atoms. And in the same way, if you are finding for P4O10, how much you will get? P4, it is 4x minus 10, 10 into 2, right? 10 into -2. So it is actually -20, which is equal to 0. 4x is 20 and x is 20 by 4. X is equal to +5. So phosphorus is also present in its highest oxidation state, that is +5. So these elements, if you see, boron's valence electron is 3, and it has lost all those 3 electrons. That's why it is in +3 oxidation state. The same case with nitrogen. The valence electrons for nitrogen and phosphorus, they are 5. Both of them have lost that. Sulfur valence electron is 6. Sulfur belongs to oxygen group, right? Oxygen group elements, basically they have 6 valence electron, and sulfur also lost all the 6. So they are present in the highest oxidation state in all these 4 compounds. So they are electron deficient in nature, since they have lost all their electrons, and those 4 oxides are acidic oxides. So B2O3, N2O5, SO3 and PO4. So these 4 oxides are acidic oxides. The remaining 3 are neutral. So the number of acidic oxides will be equal to 4. Okay, it is equal to 4. So moving on to one more question. Question number 13 for today. Yeah, statement 10. So you see, most of the statement type questions are asked from the speed block elements. All these are the previous year questions of your JEE and NEET. So most of the questions are statement type questions. So you have to concentrate accordingly and study, prepare for your exam, right? So the pentavalent oxide of group 15 element, that is E2O5, is less acidic than trivalent oxide E2O3 of the same element. Group 15 element means they are nitrogen group members, right? If I want to take this element as nitrogen, let me write like this, N2O5 and N2O3. Now there is a comparison between these two oxides. So in statement 1, they are saying that E2O5 is less acidic than E2O3. So just before few minutes we have discussed, no? The element which is having the highest oxidation state is more acidic. So in N2O5, the oxidation state of nitrogen is +5. And here it is +3. So N2O5 is having the highest oxidation. So that is more acidic. Okay, N2O3 is less acidic. So it is given the other way around. So statement 1 is actually incorrect. That is false. Okay, let's check with statement 2. The acidic character of trivalent oxides of group 15 elements decreases down the group. So let me take the trivalent oxides of group 15. Group 15 elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. Right? So if they are forming the trivalent oxide, the formula will be N2O3, P2O3, AS2O3, Sp2O3, and Bi2O3. Okay? So in all these cases, the oxidation state is +3. Oxidation state of the element is +3. Okay? So now you check for the statement 2. The acidic character of these oxides decreases on moving down the group. Acidic character decreases. Bi2O3 is least acidic. Bi2O3 is least acidic, they are saying. That is correct. The N2O3 acidic nature is only more. Okay, because nitrogen is more electronegative in nature. Oxidation state is same. Everything is same. Only the size increases. So we have to check for the electronegativity. Since the electronegativity of nitrogen is very, very high, that is the most acidic oxide. That is having the most acidic character among its group members. Okay, so statement 2 is correct. Statement 2 is correct. So it is actually the decreasing order of acidity. Okay, so 1 is false and 2 is true. 1 is false and statement 2 is true. Clear? What is the time now? Yeah, we can discuss one more question and then we can wind up this session. So the last question for today's session is assertion reason. So you see here again, statement type only, assertion reason type. So the assertion says that fluorine forms one oxo acid. Fluorine forms one oxo acid. And the reason is fluorine has the smallest size among the halogens, and since it is highly electronegative, it can form only one oxo acid. So first we have to check for the assertion. So what is that one oxo acid formed by fluorine? It is actually HOF. HOF is that oxo acid. Oxygen and hydrogen containing compounds are called as, with the group 15 or group 16 or group 17 elements, they are called as oxo acids. Okay. So now this is the only oxo acid formed by fluorine. That is correct. Because in case of chlorine, if you see, we can have 4 different oxo acids of fluorine. That is HClO, HClO2, HClO3, and HClO4. These many types of oxo acids are possible for fluorine. But for fluorine, it is only HFO. It cannot be HFO2 or HFO3 and all. Okay. Because it can have only one oxidation state, that is -1. That is possible only in this case. Okay, if we are going for HFO2, what could be the oxidation state of fluorine? Here we will take this as X, and here it is +1. And fluorine is most electronegative. It is highly electronegative compared to oxygen. So what it will do? It will try to take the electron from oxygen also. So oxygen will give its electron, and it will have a +4 kind of oxidation state, and it will be 4, -4, -1, it will be equal to -5. -5 state and all is not possible for fluorine. It is only -1. Okay, that can be attained from this molecule. Okay, so only one oxoacid is present, and since because of its very small size and high electronegativity, it cannot have more than one oxygen with it. Okay, it cannot have more than one oxygen. So I'll give you the structure also. HOF. So this is the structure. Okay. So fluorine is more electronegative with respect to this bond. It will take the electron of oxygen towards itself. So we will get -1. And since oxygen is donating its electron, it will have +1 for this particular bond. Okay. And coming to this OH bond, oxygen is more electronegative. So oxygen will gain that electron and hydrogen will lose its electron. So totally the charge of oxygen is 0. +1 -1 gets cancelled, so it is 0. And for fluorine it is -1. For hydrogen it is +1. Okay, so fluorine can form only one oxoacid of this thing. Cannot form a bond with more than one oxygen. Fluorine always form one bond. Fluorine always form only one bond. Got it? So both A and R are correct, and R is the correct explanation of A. Because of its high electronegative nature, it can form only one oxoacid. So option A will be the correct answer for this question. Okay. So this is enough for today. It's already time. You have to go for the next class. So students, I hope this session is very useful and clear to all. It is very useful for all of you. If you're having any doubts, you can ask me in the upcoming sessions. Okay. If you're not having any doubt, then we can end up the session and we can meet it in the next class. So thank you so much for listening to today's lecture. Thank you so much for all of you.